Okay, good morning. Hope you all had a great weekend. I wanted to start class today with any questions that you might have run into on the homework assignment.
I had a question over 23. I think it was on page 225.
23.
Oh wait, my bad. The other page. Sorry.
This one?
It was a word problem. I think it was.
Oh, okay. On these. All right. Number 23. Sheila was making cupcakes.
Yes, sir.
All right. I had a feeling you were going to ask about that. Somebody would ask about this one. Almost every semester I've taught this, somebody has asked me about this problem. So this is a good question. Okay, before we get into this question, let me just remind all of you that according to our schedule for this class, we have our first exam planned for a week from today. And so that will be where you have to show up and be on camera and get your camera set up properly and all that stuff. So maybe we talk a little bit more about that on Thursday. There's no way we're going to cover everything we need to cover before this exam. So I will tell you on Thursday what will be on the test exactly. I will send out a review, and then a few days later, I'll send out the solution. So I would plan on getting a review on Friday, and then solutions probably not till Saturday or Sunday morning. And that's just to force you to kind of like try and do it on your own first. So just stand by in terms of what will be on the test, but we will have that test on Tuesday of next week, okay? Now, back to the question. So I told you all that I knew people would have questions on these, but I wanted you to at least try them and see how it goes. So Sheila was making cupcakes for the school parent-student dinner. Sheila knew that she had put in 13 2/3 ounces of ingredients she had to mix together in the blender. After she was finished, she poured the mix into 2 1/4 ounce cupcake tins. How many of these cupcakes would one batch of this mix make? And then how much would be left over? Okay. So I told you all last time to try, if you're having trouble with like what mathematical operation to actually do, to maybe use easier numbers. So like if I were to do, let's say instead of that many ounces, let's say she had 20 ounces of ingredients, and let's say each cupcake was 2 ounces. Then the question, how many cupcakes would one batch make? Who asked about this? Sorry, I didn't see. Angelique? Yeah, so what would the operation be that I need to do here to figure out how many cupcakes? If we had 20 ounces of ingredients and each cupcake required 2 ounces.
I was thinking to divide.
Yep, you would do 20 and you would divide that by 2, right? That's what you would do. And that would give you. How did I get what?
20.
I'm just making up numbers.
Oh, okay.
So what I'm saying is if you're having trouble figuring out like the math, like what math do I do? Sometimes when you make the numbers easier or nicer, then the math becomes more clear as to what you're supposed to do. If I have 20 ounces of mix and each cupcake takes 2 ounces, then I should be able to make 10 cupcakes, right? That's 20 divided by 2. So you may have been fine. You may have been fine with that part. I'm just showing everyone in the class like that approach might help you to figure out what to do. So for this problem, we actually need to do the same operation, but we need to be using these numbers. So we need to be taking 13 2/3 and dividing it by 2 1/4. Now, is that what you did, Angelique? Yes?
Yeah.
Okay. So that's, now we've got it to a math problem. So at this point, all we need to do is convert both of those to mixed number, or sorry, from mixed numbers into improper fractions. Then we'll do the keep dot flip and we'll get an answer. All right, so let's do that. I'm going to take the 13, multiply it by 3. 13 times 3 is 39. And I'm going to add 2. So I should get 41 over 3, then divide that by, then again, same thing. 2 times the 4 is 8. I add 1, I get 9, so I get 9/4. Now, when we divide two fractions, this is where we do the keep dot flip. So we keep this 41 over 3 dot, and now we flip the second fraction over. Also, keep in mind, you cannot, okay, you cannot reduce this. This like 3 goes into 3 once, 3 goes into 9, 3. You cannot do that until after you've flipped. Okay, so that would be a mistake. Once you've flipped things over, then if something cancels, you can do it. But you have to wait till you've done the flip. So really, there's nothing that cancels here. Like 3 doesn't go into 4, 3 doesn't go into 41, 9 doesn't go into 41. So there's really nothing left to do but multiply straight across. So if we multiply straight across, we get 164 over 27. Okay. Now that represents how many cupcakes can be made. So it would be easier, I think, for us to understand what that is if we were to just divide. Okay. So good old fashioned old school division here. So we try and figure out how many times 27 goes into 164. So you might need your calculator, try a couple of numbers like 27 times, I don't know, 4.
I believe it's 6.
What did you get, 6?
I think so, yeah.
Yeah, yeah. So if you do 6 times, you get 162, and then you subtract, and you'll get 2, and that will be what's left over. 2, right, is your remainder here. So what we do is we write 6 and 2 over 27. So you take that remainder and you put it over the divisor, and then that's your answer. So we can make 6 and 2/27 of a cupcake. So the first question was, how many cupcakes would the batch make? Well, you can only make a full cupcake. I mean, you can make a half cupcake, but in this case, how many full cupcakes can we make? Well, we can make 6, right? We can make 6 full cupcakes. And then how much of the mix would be left over? Well, that would be what was our remainder, 2 over 27.
So because her and I actually were kind of messaging each other, like, because
Yeah.
we couldn't figure out, the answer key does not say this. That was the confusion
Really?
for
Oh.
us. The answer key this is the answer that I got, and Angelique, this is the answer you got too, right?
Yeah.
Yeah,
Let's
so
take a
we
look.
both got that, but the answer key does it, I think it's like 6 and 1/6.
Something like that.
Really?
At least on ours, 'cause we both looked at it and we couldn't figure out.
Okay. Well, yeah, that would be very confusing. Let me see if I can find this. It's page 120. I went too far. No. This is really slow. Huh. Right there.
I think one other problem did it too, but I can't remember off the top of my head. Do you remember which other problem did that?
I think it was 13.
The one that had like the 16 and
It was
1.
16 and 1/3, and then the
Yeah.
answer key said 6 and 1/3.
Yep. That
Okay, so
same
what I'll
thing.
do, I'll check with the person who puts this together and see if they're aware of this. And let me write this down. 23. We got
I
6.
think it's because 23 has 2 parts, right? It's asking one question and then it's asking another. So aren't you supposed to continue it?
What did you get for 13?
Wait, are we talking about 13 now or 23? Sorry. I didn't.
13. What did y'all get for 13?
Who said the thing about 2 parts?
I did, Shazia.
Shazia, are you talking about number 23?
Yes.
Yeah, so the first part's asking how many cupcakes could this make, right?
So wouldn't that just be the 6 cupcakes? Because you
Yep.
can't have 2 27s
Yeah,
left over.
Yeah, so that's correct. That part is correct. Their answer was 6 cupcakes. And then it says how much mix would be left over. That should be the 2 over 27 part. Let me do something.
Were you talking about 221, question 13, Emily?
221 question 13. There isn't there isn't, oh, well, is there? Hold on.
49/3.
Yeah, see, I did too, but the answer key, is that the one that the answer key said it was like? I'm trying to remember which one it
Are y'all
was.
talking about 13 now?
Yes.
Yeah, so 13, let me see, this should be 6, 7 halves times 12, 13, 14 thirds, you multiply, well, we can reduce 49 thirds.
On that one, I got 16.
I'm sorry.
I had gotten 16 and 1/3 for that answer.
Yeah, because if you
Yeah.
divide into it, then you get 16 and 1/3.
Third. I'm third. I got
Yes, it should be 16 and a third or
On the
49
answer
thirds.
key.
like 6 times.
Okay, I'll look it up. Yeah, sorry, I
I
mean,
think the answer key says 6 and 1/3.
yeah, I will, I'll let them know. I didn't make the answer key, so I won't take the blame. But thank you for pointing it out, because that, if you have questions about, you're doing the math, you understand it, but something's not coming out, please, just let me know. Okay, let's see, anything else?
On I think it was 225. Could you just go over either 13 or 15 because both of those were kind of the same?
Which one? Page 225. Oh. These right here?
Oh,
No, am I not looking at the right thing? No. You said page 225.
yes.
Okay, and you said
Number
which one?
15.
That page,
right?
yeah. 13 or 15, either one.
Okay, yeah, let's do them both.
Oh, okay.
Yeah, I was hoping that, again, I want you to ask questions about the homework because, I can do problems, but we didn't do
It
all
was
of them.
confusing, yeah.
Okay, yeah, that's why, because I was like, well, I don't think we did one like this.
Yeah, yeah. So I was expecting that people would have questions. All right, so.
Yeah, I had gotten stuck on 13 and 15 as well. And then
Yeah.
I went to, it was the math lab. My sister told me about that. And I went there
Yeah.
and they helped me out with it. Yeah.
Yeah, so remember in the syllabus, there's tutoring lab that you can go to that they'll do a Zoom session with you and help you. So,
Yeah, I was confused too because I had like no idea where to even start.
yeah, I know it looks terrible. So we have this huge division bar right here, right? That's a big division bar. And then up top, we have two fractions being subtracted. And here we have two fractions being added. We've got to figure out what all that is first. Once we figure out what all that is, then we will divide by 2. All right. So let's figure out what the top is first. If I'm going to do 2/3 and take away 1/4, I have to subtract two fractions, right? And there are two methods to do this. One is where you find the common denominator, and then the other one is that shortcut rule, that little formula I gave you. Most students like the formula, so I'm going to go with that. I do 4 times 2, that gives me 8. I do 3 times 1, that gives me 3, and I'm going to subtract. So I'm going to subtract 3, and then put all of that over 3 times 4, which is 12. That leaves me with 5/12. Any questions there on those two fractions being put together? On the bottom two fractions, I do 2/5, and I'm adding 1/4. So again, I can use the formula again. I can go 4 times 2, that's 8. And then 5 times 1 is 5. And I'm adding them this time because there's an addition sign. And I put all of that over 5 times 4, which is 20. So now I have 13/20. Oh, not 12. I don't know why I wrote 12. 13/20. Okay, so let's see where we are right now. We have this yellow fraction here became this. This blue fraction here became that. And let's just write that down. We have 5/12 over 13/20. So this really means 5/12 divided by 13/20. right? That's what that division between those two fractions means, right? You take the two fractions and divide. Now we can do keep dot flip. So 5 over 12 times, flip the other one, 20 over 13. And with multiplication, we can just go straight across. Now I am going to try and reduce this because I realize that looks like I can get a 4 to go into 12 3 times and a 4 to go into 25 times. Now, if you don't do this step, it's okay, but you'll have to reduce your fraction after you multiply across, try and get it in its lowest terms. So that should give us 25 over what, 39? So 5 times 5, 25, 3 times 13 is 39. We still good? All right, now don't forget, all of this crap right here, right? All of this, right? All of that, we've done all that work now, and we've come up with 25 over 39. And then we still have to divide by 2, right? So we can do the keep dot flip again, but we have to realize that that 2 is a 2 over 1. So we need to understand that that 2 can be rewritten as a fraction. And then when we do our keep dot flip, it looks like that. And now we can multiply straight across. 25 over, what's that? 78. So this is a problem where you have to kind of like focus on little pieces, you know, one at a time, and then kind of combine your answers all together to keep working through it. Does that help? Okay, on the next one, we have, again, something complicated looking. We've got some fractions here we need to subtract. They're in parentheses. So order of operations tells us we need to do what's in here first. And then we'll have an exponent that we'll have to do. And all of that will be divided by this 2 raised to the 3rd power. Then we have addition and division. So we're going to need to kind of follow our order of operations. So the first thing I'm going to do is what's in parentheses. So I'm going to do this first. And I'll do that over here on the side. So I'm doing the 3 times 1, and then I'm subtracting the 4 times 2 and dividing by the 3 times 4. So I'm using that formula. This gives me -5 over 12. So let me rewrite the problem. I have the -5 over 12. That's what the yellow part was. I need to square that over. Then on the bottom I have 2, but I have to cube that. Then I have to add to that 1/2 and then divide that by 3/8. Good. Let's square this, okay? Let's go ahead and square that fraction. So that means you're going to take -5 over 12, square it, which just means multiply it times itself. And again, we multiply fractions straight across. So -5 times -5 gives us +25, and 12 times 12 gives us 144. So that's what the top is. And then this in green here, 2 cubed just means 2 times 2 times 2. Which is 8. So let me rewrite this again. This now becomes 25 over 144 over 8 plus 1/2 divided by 3/8. Notice again how I made this division bar really big. We talked about this in class, that you have to be careful with the length of the division bar. So it's implied here that this division bar is the big one. So when I'm looking at this right here, you need to look at this as being really, let me do it over here. This right here is really 25 over 144 divided by 8. So we'll have to do keep dot flip. So we have to look at the 8 as 8 over 1. So times 1/8 this time. Ugh, these numbers are getting big. Okay, so 144 times 8. So we get 25 over 1,152. Any questions? All right, so where are we now? We have 25 over 1,152 plus a half divided by 3/8. All right, what do we do now?
Excuse me, I have a question,
Keep
please.
change flip.
Yeah, we're gonna do the keep dot flip. What was the question?
Yeah, the 8/1. Why is it 8/1? I think it should be 1/8.
It's because originally it is 8/1, but we have to flip it so then it becomes 1/8.
Yeah, we went from division to multiplication.
You have to make it the reciprocal.
Yeah, so you multiply by the flip. Now, is that what you're asking? Like, why is this 1/8?
No,
1/8?
the first one, the 8/1. Since we have 22 over 144 is on top. So it should be, I think it should be 25 over 144 divided by 1/8.
Okay, well, maybe this will convince you. Maybe this will convince you.
Okay.
You see this right here in this purple thing right here? See
Yeah.
that? Okay. Would you agree with this? Can I rewrite that 8 as 8/1?
Yeah.
Okay, so now you have a fraction, 25 over 144, and
Okay.
you're dividing it by this fraction, 8/1.
Oh, okay.
Then you do the keep dot flip. Does that help?
Yeah.
Okay. All right, so yeah, order of operations, we must do this division before we do the addition. So we've got to put these together before we deal with this. So again, on the side, 1/2 divided by 3/8 is equal to keep dot flip, keep it, dot it, flip it. And this becomes 8/6, and then you could reduce that to 4/3. So on this problem, I did not reduce first. I just multiplied across, then reduced, just to show you, you could do that also, right? Like 2 goes into here 4 times, 2 goes in there 3 times. You could have done it here. You could have done 2 goes into once, 2 goes into here 4 times. It doesn't matter, you'll get the same answer. Okay, we're almost there. We're at the kind of final stretch here. 25 over 1152 plus this, which was 4/3. And then to add 2 fractions together, we can do that little crossy thing where you do this times this. So that's 75 plus, and now 4 times 1152, I want to make sure I don't screw this up. 4 times 1152 is 4,608 all over this times this, 1152 times 3, which is 3,456. So plus 75. So on the top, we add that straight across, 4683 divided by 3456. Yuck. 4683 divided by 3456. Okay, that reduces, that actually reduces. But if you gave me that answer on a test, I'd be happy. All right, like if you got to that, I'd be like really satisfied. I believe 3 goes into both of those. Yeah, 3 goes into both of them. So it goes into here, 3 goes into there, and 3 goes in there. So you could reduce it to be 1561 over 1152. That's nasty, right? That was that the last problem out of that section? That's probably why it was so bad.
It is, yeah.
Yeah. So this is kind of like, if you can do this, you're in good shape. The problems you'll see on the test will probably be more in the middle range problems. I'm not going to give you like the hardest, most complicated ones I can find, all right, or make up. Okay, let's move on. No, we're ready. Any other questions? Okay. All right, so in the notes, the lecture notes for this section, order of operations, like I did, like I'd said, I didn't do a bunch of these, but I wanted to see how you would do on your own. So are there any others that you would like for me to do, either from the notes or from the homework? Any of these look like you want to see?
Mm.
Could we be able to do number 11?
Absolutely. Okay. So you've got a bunch of stuff happening here, right? You've got parentheses, and inside the parentheses, you have parentheses, and then you have like exponents. So the way I look at this is I've got this set of parentheses right here, right? I've got to figure out what's going on in there. And then I've also got this other set of parentheses here, and I've got to figure out what's going on in there. So let me start with this one first. That one, I really don't have to do anything but add those two numbers together, right? I have 4 and I'm adding -6. So what happens when you take 4 and add -6? What do you get?
-2.
-2. So watch what I'm going to do here. I'm going to rewrite the whole thing. 3 plus 2. And then what's in that red parentheses came out to be -2. And then plus, now let me do what's in the green here. Let me see what I can handle in here. I've got 1 plus, but then -2 squared. So I have to do the -2 squared first. So what is -2 squared? So what's -2 times -2?
+4.
+4. So this is really 4, and we're going to add 1 to it, right? 1 plus 4. So this thing in parentheses should give me a 5. So I'm just going to do that. I'm going to put 5 here. I want to point something out here that's subtle but important. You see here how I put 3 plus 2, and then I put this -2 in parentheses? That's very important, because if you did not put the -2 in parentheses, here's what it would have looked like. 3 plus 2, and then we said this is -2. If you don't put it in parentheses, it'll look like that. And that looks like subtraction, doesn't it? That looks like 2 minus 2, but it's not. There is an implied multiplication right there. So it's 2 times whatever this number is. So you have to put that in parentheses to be able to see the multiplication that's happening here. Just, again, one of those little subtle things. Here, the 5 that I have in parentheses doesn't really need to be in parentheses because there's not a number out front being multiplied through. So I don't need it, but it doesn't hurt to have it there. So the next thing that I do in the order of operations is this multiplication. And 2 times -2 is going to give me -4. So this becomes 3 plus -4 plus 5. I'll drop the parentheses here. And then I just work from left to right. 3 plus -4 is -1, and then plus 5. And then -1 plus 5 is 4. We good?
So with question 12, I'm a little confused, like with when it has like the bracket, it has the -5, or not the bracket. It has -5 in it.
I just
Which
want to
one,
make sure I
what?
did it right.
Wait, say it again.
On the page 223, the page we're on. So question 12, I'm a little confused with that -5, how to do that.
Oh, okay, yeah. So I was going to ask you if y'all knew what this meant. So the parentheses we see here, and here, right? We got to do that, and we got to do what's in here. But within this first parentheses, there's these vertical bars. And those vertical bars are not parentheses or brackets. Those vertical bars mean something. They mean the absolute value of the number. So anytime we see two vertical bars around some number, say there's a number in there, okay? Your answer will always be the positive of that number. All right. For example, if we see the bars around the number 4, well, it's just going to spit out the answer 4. But if we see the bars around the -4, it'll spit out +4. So that's called the absolute value. And so in this problem here, when I'm trying to figure out what 4 minus this is, the first thing I would do is I would do 4 minus, now the absolute value of -5 is 5. So I would just write 4 minus 5. So 4 minus, and then this thing becomes 5. And then I have minus over here, I do 1 plus 4, that's 5, and then square. 2 times 4 take away 5 is -1. And then minus, if I square the 5, I get 25. 2 times -1, I do multiplication first here, is -2, and then take away 25. So I get -27. Does that answer your question? Yes, okay. All right. Anything else? Now's the time. I don't mind doing one more if you want to see one.
On number 3, what would you do first?
Yeah, good question. So this is actually, there's something going on here that's you can get yourself into trouble with a problem like this. All right. Some people will do this. They'll say, oh, I do the square root of 5 squared, and then I subtract from that the square root of 3 squared. So they basically break this up into 2 square root problems and put subtraction between them. And this is completely wrong. You can't do
Yeah,
that.
that's what I did. And then I went to the tutoring and they showed
Yeah.
me.
Yeah. So that's a property of square roots that's kind of tricky. Let me write it in more of like a formula way. If you have the square root of 2 things that are either added together or subtracted, okay? If you have addition or subtraction between these 2, you are not allowed to break this up into 2 square roots. You are not allowed to do this, okay? Now, if you have multiplication between them, then yes, you are allowed to do them individually and multiply the answers. Okay. So for example, if you had the square root of 9 times 4, you could do this as the square root of 9 times the square root of 4. The square root of 9 is 3 times the square root of 4 is 2. So your answer should be 6. Okay, which is right because 9 times 4 is 36. And so the square root of 36 should be 6. So that's allowed. This is okay. This not okay. So that means the only thing you can do here is actually square the 5, subtract from that the 3 squared. And what is 25 minus 9? 16? And then the square root of 16 is 4. So your answer here is 4. Okay. So make sure that you've run through the homework for the Started on, what was it, 225, right? Yeah, just make sure you've gone through these homework problems. And in preparation for the exam, I recommend that you go and maybe try and work out some of the problems from the notes that we didn't do. If you just want more practice, go take a look at some of these problems. All right, we're going to move on. We're now going to talk about solving linear equations.
Are you still on page 223?
Let me check what page that was. I believe it is. Yes, 223. Mhm. All right, so we want to solve linear equations. So before I even get into this, all right, I want to make sure we understand what a linear equation is. All right, it'll be important later because we're going to be working with other types of equations in this class. And each type of equation we look at requires a different procedure in order to solve them. So a linear equation is this. First of all, you're going to have an equal sign. Okay, there must be an equal sign. Okay, that's what makes it an equation. You have to have the equal sign there. And then the next thing is that the variable has a power of 1. Sorry, has a highest power of 1. So let's start off with like a very generic, simple linear equation. X plus 1 equals 2. Okay, so if I ask you to just look at that equation and tell me what does X have to be in order for this to be true, I think most of you would just look at that and be able to tell me the answer is 1, right? Like 1 plus 1 is 2. But see, equations get more complicated than this. So you get to a point where you cannot look at it and give me the answer, right? So look at that one versus this one. 3x minus 7 equals x plus 4. Okay, can somebody tell me what x value you plug into that to make it true? Probably not by looking, right? You can't just look at that and give me an answer. This one on the left, you probably could. So we need a systematic approach, a procedure kind of to follow, a set of rules, steps, so that if someone gives us something complicated like this one in yellow, we can all arrive at the same answer. So those steps to solve linear equations are important, right? Like you need to kind of learn them, understand them. But the first thing is you must be looking at a linear equation for any of the steps that I'm about to give you to work. So we have to have an equal sign and the variable has to have a highest power of 1. So in the first problem, we have an equal sign. And then if we look at the x, that's our variable, the power on that x is a 1. So that makes it a linear equation. The second one, we have an equation, an equal sign, so that makes it an equation. Then we will look at our x's, there's a power of 1 here and a power of 1 here. That makes it linear. If we saw x squared or something like that, we'd no longer be linear and we would be doing something completely different to solve it, all right? Linear equations are the easiest of all equations to solve, okay? They get more complicated when you start making these powers become squared or cubed or fourth power, okay? They get much harder. In this class, we'll pretty much stay with x squared as the highest power. We will do some problems that have a little bit higher powers, but they'll be kind of made very easy so we can work them out. If you were in the 1414 class, we would go up to like powers 6, 7, we would go really higher with them. So we're going to keep it kind of at the base level here. All right, so what are the steps, okay, to solve a linear equation? To solve a linear equation, here's what you do. First thing is you will clear fractions or remove decimals. Now I'm going to write the steps down first. Once I write the steps down, then we'll actually go through and do some examples, and you'll kind of see how the steps work. Most of you have seen how to solve linear equations before, but I mean, I'm kind of starting like let's just start like you've never done it before. Okay. Well, kind of. I do expect certain things that you know how to do. All right. All right. So clear the fractions, remove the decimals. That's the first step. Second step is to collect like terms. On each side of the equation. So the first step is to get rid of fractions or decimals, because we don't like working with fractions. They make us make mistakes. So we get rid of all the fractions and decimals first. Then what we do is we look at both sides of the equation. We see if there's anything we can put together. Like if we have a 2 plus 5, we'll add it together, get 7. If we have an x plus 3x, we'll add it together and get a 4x. So we collect everything together on both sides. Once we have everything collected, then what we'll do is we will isolate the variables, variable term, variable terms on one side. You get to choose. Okay, so there are two sides of the equation. What you're going to do is you're going to try and move everything that has the variable in it to one side, and everything that does not have a variable in it to the other side. And that's called isolating the variable. Okay, fourth step is to, once you've isolated, you will then get, how do I say this? Get a coefficient of 1 on the variable. And what that means is you're either going to multiply or you're going to divide both sides of the equation by something. And at that point, you should be done. You should have your solution. All right. So let's do these problems up here. All right, because these two kind of what I started with. Let's let me grab this. Put it here. I'll make it a little smaller. Did I tell you, I feel like I did, that on your test, you're going to be allowed to have like a little reference sheet that you can make? I told you all that? I don't know if I did, but I will allow you to make a little formula sheet of your own. And on that sheet, you're more than welcome to have the steps written out, all right? We'll talk more about that on Thursday. Okay, let's start with the first equation. I know I'm not trying to insult your intelligence here, but x plus 1 equals 2. Like we all know the answer, that's 1. But let's just follow the procedure, all right? So first step, clear the fractions or remove decimals. Well, do you see any fractions? Do you see any decimals? No, right? So we just skip to the next step. Collect like terms on each side of the equation. Now, what that means is I look at the left side and I look at the right side separately, and I ask myself, is there anything I can do? So in the yellow, can you put x and 1 together? Can you add those together? Well, they're not like terms, right? It's like one of them is an apple, the other one's an orange. You can't combine those together. So there's nothing I can do to combine like terms on the left. And on the right-hand side, 2 is 2, and there's nothing over there to combine it with. So step 2, there's nothing to do. Step 3, isolate the variable terms on one side. So I only have one term that has a variable in it, and that's that one right there. I need to get it by itself. Okay, by itself on one side of the equation. Right now, there's a 1 next to it, right? So I'm going to leave the x on the left side. That's my choice. I'm going to leave the x on the left, and I'm going to get rid of the 1. So how do I get rid of that 1?
You subtract it from both sides.
You subtract it from both sides. Now, I know a lot of you know that, but let's just think about why we're subtracting. This is adding 1, right? How do you undo addition? You undo addition with subtraction, right? So I will just subtract 1 on this side, subtract 1 on that side, and then we just see what's left, right? These ones cancel, you're left with X. Then over here, 2, take away 1, you get 1. So now I've completed step 3. I've isolated the variable on one side. Now step 4, get a coefficient of 1 on the variable. What that means is make sure that the number that's in front of the X is a 1, which if there's no number written, it is a 1. So we're done. I mean, there's nothing more to do here. So we have our answer, X is 1, which we knew that to begin with, all right? So let's do the other problem. 3x minus 7, x plus 4. So this problem, when we looked at it, we couldn't just look quickly and get an answer, right? Like nobody could just look at that and be like, oh, X is this, right? So we have to have a procedure. We have to have a way of doing this. So the first step is to clear fractions. Let me call on some people. Let's see here. Dylan, are you here?
Yeah, I'm here.
Okay, Dylan. Step 1. Clear fractions, remove parentheses. What do you think?
There's no fractions or parentheses. You have to collect the like terms.
Yeah, so we move to step 2. Collect like terms. Can you collect anything on the left or right?
Yeah, you can move either one of them.
Okay, so careful, Dylan. Step 2 is to collect like terms on each side. So what you want to do is just look at each side individually. What you're doing is you're ready to start moving things around, right? I think that's what you're wanting to do. Step 2 is just to make sure that there's nothing you can combine together on either side. Like, can you put the 3x and the minus 7 together?
Oh, no.
No, right? And the 4 and the x can't go together.
Yeah.
That's step 2. So we can't do anything there, right? So we move on to step 3.
Mm-hmm.
Okay. Any questions on that? Okay. So step 3, isolate the variables. So now, Dylan, how would you like me to isolate the variable? You get to choose. Do you want all the X stuff on the left or on the right?
Yeah, I'll put the X on the left.
On the left, okay. How would you do that? If you want all your X's on the left, that means you're gonna need to get rid of the X on the right. So how are you gonna do that?
Subtract it.
Subtract. So you're gonna subtract X on the left, on the right and the left, like that.
Mm-hmm.
That will get rid of the X's here. Now, Dylan, that's still gonna leave you the minus 7 over here, which you don't want, right?
Not good. Add 7.
So you
Go
add
to the
7,
right
you
side.
do the opposite of subtraction, which is adding. That'll kill off the 7s on the left side.
Mhm.
Okay, Dylan, what do we get there? What's our new equation after we do this?
You get 2x equals 11.
11. Okay, good. That's step 3.
Mm-hmm.
Now, step 4 is that you have to make sure that you have a coefficient of 1 on the variable. So you need to make sure that that's a 1 in front of the X, not a 2 in this case. So Dylan, how would you get rid of the 2?
You'd have to divide by 2. On
Divide
both
by
sides.
2. Good. So everyone, again, why are we dividing by 2? Because the operation between the X and the 2 is multiplication, right? And so we're trying to undo multiplication, which means we need division. Here, when we had the minus 7, we added 7. Why? Because the opposite of subtraction is addition. So we are doing division here by 2, division by 2. 2 divided by 2 is 1. That leaves us with the X. If you want, you could put the 1 in front of it, but you don't need it. That would give us X. And then the right side is 11 over 2. I do not want the decimal answer. I don't want you to get on your calculator. I don't want a mixed number. I just want that improper fraction. We're done. See, so look, the idea here again is that on the first linear equation, we could all just look at it and say like, oh, X is 1, right? But nobody in this class, even me, like initially when I wrote this equation down, there's no way I just look at that and be like, oh yeah, X is 11 halves. Like there's just no way, right? So we just need to be able to have a method to be able to solve more and more complicated linear equations. All right, so that's it. That's the method. Let's do a couple of more. And then, I don't know, it's already 10:20. So let me do a couple more that are a little more complicated, and then maybe if we have time, I'll let you do breakout rooms. We'll see. Let's do one. I'm gonna squeeze one in right here. How about this? 3 parenthesis x minus 4 plus 7x minus 1 equals -2 times 3x plus 3 plus 5. Okay, that looks pretty good, right? Kind of throwing you right into the fire here. So this right now, first we have to make sure is a linear equation, right? So we do have an equal sign. And if you look at all the x's here, x, 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 all those x's, all of them are raised to the first power. So this is a linear equation. And so we can follow the rule, the method. Any questions? Okay, so let's see here. Is it onerous? Onerous? Onerous?
Yes,
Am I saying that right?
Aneris.
And okay, hold on.
Aneris.
Anaris. I'm gonna like rewrite it here on my end so I can really like see what I need to stress. Anaris.
Aneris.
Anaris.
That's better.
Anaris. All right, I'm gonna do my best. Okay,
That's
so
fine.
you're up. You're up. First step, clear fractions or decimals. Do you see fractions or decimals?
I really don't understand this. You need to explain to me.
Okay, so do you see a fraction anywhere here? Do you see like something divided by something? Like, you know, do you see, oops.
I
Do
don't
you see
see.
like 5/2? Or do you see a decimal like 4.75? Do you see anything like that in here? No fractions, right?
No, I didn't see no.
No decimals where it's like, you know, 2.75 or something. You
No.
don't see it, right? So we can skip step 1. You okay with that?
Yes, I'm okay with that.
Okay. Step 2 is to collect like terms on each side of the equation. Well, we have a problem. For the first time, we have a problem. Because on the left-hand side, we have multiple x's, don't we? And we have
Yes.
also numbers. So we need to try and collect these together. But you can't do anything until you get rid of this parenthesis. So what can we do to get rid of the parenthesis here?
So with the parentheses, you do a distributive.
You can distribute, right? We can take the 3 and multiply it through the parenthesis like this. And while we're at it, let's do it on the other side too. Let's take that -2 and multiply it through the parenthesis here. So when we multiply 3 times x, we should just get 3x. And we multiply 3 times -4, we should get -12. Then we can continue writing everything else that's here. And then distribute here, we should get -6x minus 6 plus 5. And Aris,
Yes, sir.
that makes sense?
Yeah, that makes sense.
Okay, now, still in step 2, Aris, can you collect like terms together? So can you tell me what we get when we put those x's together on the left-hand side? How many x's should we have?
2. Oh,
You have 3 of them, right? And you're
3
adding,
right here, and then, okay. And
Right.
7?
so 3 of them plus 7 of them should be 10 of them, right?
Yes.
10 x's. And then you also have to figure out what 12 take away 1 is. We can put those together, right?
Okay.
So if you have -12 and you take 1 more away, you should be at -13. And then our equal sign. And now let's do the right-hand side, same thing. We only have 1 x term. Can't do anything with that, but we can combine these together. So -6 plus 5 is We have anybody,
It's -2, if I'm not mistaken.
-6 plus
No.
5.
Oh, no, I'm sorry, no, 6 plus,
It's like money. Think of it as money.
Zero.
You owe someone 6, someone owes you
-1.
5,
-1.
-1.
4, 3, 2, 1.
All right.
Oh, there we go. Sorry.
All right. So John, how about John Mesa? Where's John? Any John here?
I'm here.
Okay. There you are. Okay. So John, you're up. Are you okay with this so far, John?
Yes.
Okay. So we've done step 1. We've done step 2. Step 3, isolate the variable. Your choice. Which side of the equation do you want your x's to be on?
The left.
Left? Okay. So how are you going to do that?
Would we distribute the -6x on both sides?
You would move the -6, or you would get rid of the -6 here. I don't want to say distribute. You just want, you want this -6x to no longer be here, right? You want it on the other side. So how are you going to do that? How are you going to like do the reverse of subtracting 6x?
Oh, add 6 on both sides.
Add 6x to both sides, right?
6x,
Add
yeah.
6x to both sides. That will get rid of the -6x on the right. And then John, you still have on the left side, you'll still have this -13, which you don't want, right? So how do you get rid of the -13 that's on the left?
Add the 13 on both sides.
Add 13 to both sides. Okay, John, tell me what my new equation looks like.
So it should be 6x equals 13.
So 16x,
Oh,
that's those two added, right? 16x.
Oh, -1 plus 13 would be
12.
yes.
Okay. I'm sorry, I didn't hear you said that. Okay, good. One more step, John. We need step 4. We need a coefficient of 1 in front of the x. So we want to get rid of the 16 that's being multiplied. So we will divide by what?
We could divide by the, it would be the 12.
Nope, you're
No.
trying to get this 16 away from the
Oh,
x,
that's right. Oh,
Yeah.
oh, so it would be 16 then on
There you
both
go.
sides. And then the 16 cancels, that leaves you with x over 12 or 16.
Yep, there it is. Now we can reduce that. 4 goes into the top 3 times into the bottom 4. So our final result here would be 3/4. Okay, let me look at some of the problems they have here. So these are kind of the same thing. Let me do one of these. Let me see the next page. I'm going to try and do these two before class ends. I have 15 minutes. See if I can do these two. All right, so let's look at this first one. All right, we have 2 over 5x minus 5 over 7x equals x minus 1. Okay, we're trying to solve this one. Let's see, Desiree? You here? Desiree?
I'm here.
Oh, there you are. Okay, Desiree, how are you feeling about this?
Mm, sorry, I'm just getting a little bit confused.
Okay, well, let's just see how this goes. All right.
Okay.
So the first step, Desiree, is for us to do what? What is our first step in our procedure here? Do you see fractions? Do you see fractions in our problem?
Fractions.
You see the 2/5 and the 5/7, right?
Yes.
Okay, so we have fractions, so we have to clear them. Now, this is the first time that we've had this, everyone. So can somebody help to say how they've learned that you would clear these fractions? Anyone know how you would clear these fractions? No?
Whenever I had problems with fractions, we just solved them with the fractions. We never
With the
cleared
fraction.
them.
Okay, which you can do, okay? It's just sometimes that creates issues because students struggle with fractions. So if you want to do it with fractions, go ahead. The clearing the fractions, in my opinion, just makes things easier later down the road of the problem. So here's what you do. Okay, if you want to clear the fractions, here's what you do. You look at the denominators of the fractions, okay? You look at those. I only have two denominators, 5 and 7. What we need to come up with is a least common multiple of the numbers 5 and 7. So this is where you we did this before. We were when we were learning how to add fractions, you have to find this common denominator. You list out all the multiples of 5, right? And then you list out all the multiples of 7. And you try and find the smallest number that appears in both lists. So can somebody tell me what is the smallest number that would appear in both of these lists?
35.
35. 35 would be in both of these lists. 35 is down here, and then 35 is down here. Okay, got it? 35 is the least common multiple of both of those. Now, the question is, what do we do with that 35? And here's what you do. You will multiply both sides of the equation by 35. So I take the entire left side of the equation and I multiply by 35. I take the entire right side of the equation and I multiply by 35. Now, you might be asking, so why are we doing this step? This step, when we're done with this step, we will no longer have fractions. Okay, guaranteed we should have no fractions left. So let's do the process. I need to multiply this times this. I need to multiply this times this times this, and this times this. All right, that's what I need to do. Distribute the 35 through. So let me do that first multiplication, 35 times 2/5 x. When I do that, I get 35 times 2/5 x, then minus 35 times 5/7x equals 35x minus 35. Okay, see if you understand there what I did? This times this, minus this times this, that's this, right? And then 35 times x, and then 35 times -1. Any questions there? Okay, now something good is about to happen right here. That multiplication, think about what that really means. That's 35/1 times 2/5. That's really what that means. So 5 goes into 5 once, and 5 goes into here 7 times. And now when you multiply straight across, what do we get? 14/1, which is just 14, right? So we'll just get from this, we'll get 14, and then the x that was with it. Don't forget, right? That x that was next to it. When we do this multiplication, 35 times 5/7, we again can look at the 35 as 35/1. 7 goes into 7 once, 7 goes into 35 5 times. And then when we multiply across, we get 25/1, which is 25. So this becomes minus 25x. Again, don't forget the x. And then on the right-hand side, 35x minus 35. Okay, questions? We've done step 1. We have cleared the fractions. Step 2 is to collect like terms. So I look on the left side and 14x take away 25x. I can actually collect those together because they both have x's, right? So I have 14 of something and I take away 25 of them. I should have what, negative 11 x's? And then on my right side, I cannot collect these together, so I leave them alone. So now I've done step 2. Step 3 is to get the variable on one side. So let's see, I'll let, is it Kahindi? Am I saying that right?
Yes.
Did I say that right?
Yeah.
Okay. You doing okay with this?
Yes.
Okay, so you get to choose which side you want your variable to be on. Do you want it on the left or the right? Your choice.
On the left.
The left. Okay, so if you want it on the left, you already have this here. That means you need to take this 35x and get it to the other side. How are you going to do that? If you want to remove it from the right side, what are you going to do?
Right there.
You stuck there? Someone want to help? Dorley, you look like you want to say something.
Yeah. Wait, what side are we putting it on again?
Kahindi said that left side.
The left?
So, yep.
So minus 35x?
Yep, you will subtract 35x here. That way it'll go away. And then whatever you do there, you have to do here also. So it'll cancel out. Okay, Dorley, you want to continue since you decided to do this? What would this?
So it would turn into that one, the negative 11x minus 35x would be negative 46x.
Negative 46x.
And then equals negative 35.
35. So that's the only thing that was left over here was negative 35. You have to put these together. Take negative 11x, subtract 35x. That leaves you with negative 46. Okay, go ahead. You're almost done. What's the last thing here?
I'm not sure about this one. Would you divide negative 46 on both sides?
Exactly. Divide negative 46 on both sides. Good. That will make this negative 46 over negative 46 turn into a 1. Were you unsure because you weren't sure if you should do positive or negative?
No,
Or-
I just wasn't sure if that's how you get it to the other side.
Yep. That's how you turn it into a 1. I like to look at it as you're trying to make this negative 46 turn into a 1. So you have to divide it by itself. If you divide it by itself, it'll turn into 1. And then you have to do that on this side also. So you wind up getting here x equals, and then here, this negative 35 over negative 46, we might be able to reduce it, but I am going to put that it's positive because a negative divided by negative is positive. And then, yeah, I'm just leave it. Okay. It's 10:40. So I think this is a good time to probably start to wrap things up. What I want you to do for homework tonight, of course, is to make sure that you can do all that order of operations. And then where's the section of homework here? Here we go. So on page 226 for homework, page 226, let me tell you which ones to not do, okay? So skip 20 for now because it has decimals. We haven't talked about that. What else? Are there any others with decimals? Skip 35. So 20 and 35 skip. Yeah, and that's it. Now look, I'm going to tell you right now that this is going to be, this homework is going to be difficult, all right, for some of you. Just by talking to the class, I can tell like Some of you are comfortable, some of you are uncomfortable. So really this assignment is just to kind of get a feel for what you can and can't do. When we come back, we will do more of this, but I really would like to have questions from you like, hey, I tried this, I have no idea what to do. I've given you the steps. It's just a matter of, do you know how to actually execute those steps? That sound fair? We come back Thursday and I answer questions. Please visit me in my office hours if you want help. I can work through problems individually with you and, you know, trying to figure out how you think about things. Yeah, I mean, if I were you, I would like look at the ones that look easy and like start with those, like maybe that one, that one, that one, that one, like avoid the fractions, you know, as long as you can. Like those are probably these are the ones that are kind of start off kind of easy. And then just kind of like pick and choose the ones that you think you feel like you could handle. And then the ones that you can't, just kind of wait till the end and do those, you know, after you've done the others. Okay. I think that's it for today. So everyone have a good day. I will see you again on Thursday. We'll continue with linear equations. We'll talk about the test.
Have a good rest of your day, sir.
You too.
Bye.
Thank you.
Bye.
All right, I'll
Thank
hang out for
you.
now.
Bye
See you
the rest of your
Thursday.
day.
Thank you.
I'm excited to do this homework. I love doing linear